All right, so we've looked at our unit circle, which is awesome. Now, we are going to look at some right triangle trigonometry and just kind of how the two work together and what all of that means. So the first thing that we're going to look at here is if I have this right triangle, right? So I know this is the x value, right? And this is going to represent the y because it goes up to the y. Let's make sure that you understand this goes all the way down. It's this full distance here, right? So that's our y, that whole distance. What I'm missing is the other side. So we have a right triangle. When you have a right triangle, then you can use Pythagorean theorem, right? And remember, Pythagorean theorem is a squared plus b squared equals c squared. And in this instance, let me scoot this up a little, we have x squared plus y squared is equal to r squared. Because over here on this hypotenuse, that one's kind of janky, isn't it? Let's try that again. This, not much better. That is my r. All right, so when you have your right triangle trigonometry, we're going back to what we did there at the very beginning. If I have the sine of, and in this instance, we're just going to call this theta, this angle measurement. So sine of theta is going to be y over r. That's going to be my value with right triangle trigonometry. Cosine of theta will be x over r. Then, as soon as you know sine and cosine, you literally have all the rest of them, right? Because tangent, we know to be sine over cosine because we've learned that now. You now have that memorized. I'm just making that assumption. Sine over cosine, meaning you have y over x. And cotangent is the reciprocal identity. So now I have x over y of tangent, and secant is a reciprocal of cosine, meaning I now have x over r. Oh, sorry, I said that backwards. R over x. And cosecant is the reciprocal of sine, so then that is r over y. All right? Okay. So let's do this thing. Here's example 1. The terminal side of angle theta in standard position passes through the point. And standard position just means around that origin. Passes through the point, -3, -4. All right, I'm charged with finding the values of the 6 trig functions of theta. Find, oopsie daisy, find all 6 trig functions. Okay. So first thing I want to do is whenever I set this up, it says it's in standard form. So I'm going to draw my XY coordinate here. I know that this is at -3 over here for the X, and I'm going to go down here to -4 for the Y. So my triangle here is going over to -3 and up here to -4. So -3, -4 is going to be this coordinate point, right? So I now have my triangle goes like this. So we know with this right triangle here, my value on this side is represented by -3. My value over here is represented by -4. But my question is, what's the hypotenuse? Well, how do I figure that out? Yeah, Pythagorean theorem. You got this. So I know that x squared plus y squared is equal to r squared. So negative 3 squared plus a negative 4 squared is equal to r squared. 9 plus 16. So I've got 25. Then I square root. Now here's the deal. Typically, anytime you make a square root symbol, you write plus or minus. In this instance, we are specifically talking about this distance. The distance of your hypotenuse is always, always, always positive. All right, so you don't have to worry about that plus or minus situation here. It's always going to be positive. So here I know that my r value is 5. All right, with that being the case, I'm going to scoot this over here a tad because I didn't realize I was running out of room this much. So I'm going to scoot this over here. Now we can find all of our trig values. So sine of theta, cosine of theta, tangent of theta, cotangent of theta, secant of theta, and cosecant of theta. So sine, we know, is y over r. So I have my y value, which is still negative, over my r value, which is 5. So then this is now going to be negative 4/5. Do you see that? It's just the y's over the r's. Cosine is x over r. So my x value over my hypotenuse. Tangent is y over the x. Look what happens here. Negative 4 over negative 3. What happens when you have a negative divided by a negative? Positive. So my answer for that one is actually a positive 4/3. I'll box these so you know that's our final answer. Cotangent is the reciprocal of this. It's also your x over your y because it's cosine over sine. So I actually have negative 3 over negative 4, which we know is a positive 3/4. Secant, just look at this up. Secant goes with cosine. If this is negative 3/5, what do you think secant is? Negative 5/3, exactly. If cosecant is the reciprocal of sine, and this is negative 4/5, and negative 5/4. The negative sign in front of the fraction, it doesn't matter if it goes in the numerator or denominator, just the whole thing is negative. That's the point of that, right? Okay, good. Let's keep on keeping on. So, what if I have example 3? I want to find the values of all 6 trig functions. Of these 2 scenarios. Scenario A, an angle of 90 degrees. Well, let's look. If you have 90 degrees right up here, right? This is my angle of 90 degrees. What is that coordinate point? Yes. And we're going to make the assumption that this is on the unit circle. When we have something like this, it's always just the assumption of the unit circle. All right? Okay. So, if I'm having sine of 90, cosine of 90, tangent of 90, what else do we have? Cotangent, secant, and cosecant. Now, I want to point something else out to you here. Any angle of 90. If I have, oh, doggone it. If I have this, sine is going to end up being y over r. So in order to get up there to this r value, I'm looking for this distance. This distance is going to be the exact same value of however high I get up there for my y value. So in this instance, r is equal to 1. So sine is 1 over 1, which is 1. And can I get a no duh? right? So it doesn't matter what it is that I'm looking at. This could be, oh shoot, I don't know, 25. What if I made that 25? What would R be if the distance up there to get this 25? Bam! So then this would end up being 25 over 25, and what do you still end up with? There you go. Do you see what I'm getting at? So that's why it says just any angle of 90 degrees, because it doesn't matter. That's all going to be the same. Okay, I'm going to take this blue off of there because I don't want it to mess you up with your notes. Okay, and what's the other thing that we know? We know if I'm looking at this angle measurement here with our sine, we automatically know sine goes with which one? The y's. So if I have this unit up here, I automatically know that my y values are going to be here. If it's on this quadrantal, right? If it's on that quadrantal angle. Okay. Cosine is 0. So it'd be like 0 over 1, which we know to be 0. Tangent is sine over cosine. So 1 over 0 is going to give us a what? Yeah, it is. Undefined. And we just did those graphing. So at 90 degrees, that's the same thing as pi over 2, right? What do we know is happening with tangent at pi over 2? Asymptote, baby. So good. It's all working together. I'm bringing this up because I want you to see how this all relates together. Cotangent is 0 over 1. Well, that's all right. We can have 0 over 1 here. And that's just going to be 0. And that's where cotangent crosses that axis. Secant being the reciprocal here of cosine. So I have 1 over 0 also becoming undefined. And cosecant is 1 over 1, still 1. All right? So any 90 degree angle, we're going to come up with that. Okay, look at this one, next one. So if I can do all 6 for 90 degrees, what happens if I have an angle, theta, in standard position, with the terminal side going through the point -3, 0. Well, let's see what that looks like. If I have the point back here, -3, 0, what is that angle measurement? It's going to be pi or 180 degrees, right? Depending if I'm talking about degrees or radians. So same thing. I want to come up with all of this. I have the sine of pi, the cosine of pi, tangent of pi, cotangent of pi, secant, and cosecant. All right. So let's own this thing. If that whole thing here is going to be theta, then my sine value that I'm looking at, what is going to be my r? My radius, my distance through there. 3. Even though I'm going out to -3, my r is going to be +3, remember, because it's that distance. That's how far out we are going. Okay, so do it up. For sine, yeah, we'll keep old red going. Oh, we'll go black. Why not? Then we have 0 over 3. So that's 0. Duh. Okay, just pointing that out. Then I have cosine is going to be -3 over 3, giving me a -1. And what would it be if we were looking at our unit circle? -1. Okay. See how all of this relates? I just want to keep bringing this to your attention because these are not disjoint concepts. It all works together. Right triangle trigonometry, unit circle, everything works together when you're talking about trig and these angle measurements. Okay, tangent is sine over cosine. So I have our 0 over -3, because it's y's over the x's, giving me a 0. Cotangent is just the reciprocal of that. Secant goes with cosine, so that's 3 over -3, still with a -1. Cosecant goes with sine, and I've got 3 over 0, giving me undefined.